Welcome to Ask SME Anything. Your chance to ask the IT Pro TV subject matter experts questions live. Here's your host, Don Pezet.
All right, good morning, good afternoon, and good evening, and welcome to Ask SME Anything, the show at IT Pro TV where you get the chance to interact with the SMEs and ask your questions and hopefully get answers, or, you'll definitely get an answer, hopefully a correct answer, as a chance to basically reach out and talk to some of the talent that you see in shows just time and time again. And in today's episode, we have Mr. Ronnie Wong here in the studio with me, one of our best edutainers whose focus area is typically in Cisco, networking, Office 365, and a handful of other areas. Ronnie, thank you for joining us.
Well, Don, thank you for having me on the show as we get started here. It's kind of interesting, a little bit nerve-wracking that I'm going to be getting questions directly from our viewers because I never know what people will ask, and so I am hoping to give you a right answer as well.
Awesome. Well, we are going to throw you on the spot.
Okay.
We're going to make you uncomfortable. But the key thing to remember is where these questions are coming from, which is from you, the viewers out there. If you have a question for Ronnie or really any of our SMEs, please let us know. Jump onto Twitter and do a post, hashtag AskSMeAnything, SME for subject matter expert. If you tweet to that, our social media team sees it and they feed it to us live during the show that's being monitored and watched. So if you're watching live, throw it in there. You get a chance to have a question appear in the show. If you are watching this recorded, don't fret. You can still use it, right? Because we gather those questions and posts all through the week. If we have a question that's outside of the topic area of this particular SME, then we just save it for when the next SME is here. We rotate through the entire staff here at the company, so you get a chance to ask everybody. So Ronnie, that means no Lotus Notes questions today.
Oh, well, I'm actually grateful for that. I'm hoping for Ghostbuster questions myself.
All right.
I think I may actually be able to handle a few of those.
That new Ghostbuster certification
Yes.
they've been working on, this is going to be the time. All right, but we are actually going to start off with one that's a little more closer to your range. We got a Cisco question that came in through Twitter, and this one is, what is the difference between the data plane and the control plane? So it doesn't actually say it in the question, but this is definitely a Cisco question talking about the hardware found in Cisco routers, right, Ronnie?
It really is. So when we start taking a look at this idea of the data plane and the control plane, there's also one other plane that we call the management plane. When you first begin learning about Cisco equipment, you kind of think, oh, packets go in the interface and they go out the interface. What's the big deal? All they have to do is look at a routing table. But there's a lot more in between that you have to kind of think about. So when we start talking about the idea of the data plane and the control plane, usually this is where we can affect the data and where the data passes through. So for example, when we send data into an interface, that's going to the data plane right then, and it's on the data plane that it can then, of course, be either going to an IP address or out the exiting interface. So it's data that's passing through the router is normally where we see the idea of the control plane come in. Now, before we can do that, of course, it has to be affected somehow. And that means we have to make sure it goes out of the right interface or it's heading towards the right network. And that is where the control plane comes in. So it's a different way to say, hey, as that packet comes into that interface, then it can be affected by routing protocols, and that way when we actually are implementing like routing protocols, that's done on the control plane, and it takes a look there and then make sure that the data can get routed to the right interface or exiting the interface as well. So it's really about the control of the data as well as where the data passes through when we start talking about the control plane and the data plane too.
All right, so Ronnie, to kind of summarize there, what you're saying is like on a router, the routing protocol, so the logic and the thinking, that's happening at the control plane.
Right.
And the data plane, that's basically just transit. Data's moving as fast as it can?
Yes. Yeah, and when we start seeing that, right, it's kind of weird because the first time I heard about it, I was like, why does it need so many planes? It just didn't make sense to me. But it's because the router is having to make a decision, and what we don't want to do is we don't want to slow down the traffic. We don't have to. But because every piece of data that comes in has to be routed, we want to also have that implementation. So, yeah, doing the routing and the routing protocols on the control plane helps that. And then, of course, on the exiting interface, it knows where to go.
Yeah, and if you've ever asked yourself, this isn't the question, I'm going to make one up though.
Okay.
If you've ever asked yourself, why is Cisco equipment so much more expensive than other vendors, right? Part of it is how they handle that data processing to make it move faster. There's a protocol called Cisco Express Forwarding, CEF. And what CEF does is it says if I've got a stream of traffic, the very first packet, it's got to jump up to that control plane so it can figure out where to route it and send it along. But if it's just one segment of, say, 1,000 segments, the other 999 segments, they don't have to go to the control plane. It already knows where that data is going to go, so it can stay on the data plane, move right from interface to interface, and move a heck of a lot faster. Now, the competition's caught up quite a bit,
Right.
and so at this point, I'd almost venture to say all routers are created equal these days, but for many, many years, that gave Cisco the big cutting edge. So those different planes are pretty important. Ronnie, you mentioned one other plane, the management plane.
Right.
That wasn't in the question. What is the management plane?
Yeah, the management plane for us, of course, is how we get access to the router itself to configure it. So when we try to configure it, you may even consider the console port that we plug into as being part of that management plane, so that you can begin to configure the routing protocol and the IP addresses on the interfaces and everything else there too. So it's another way that we can manage the device is through that routing, not through the routing plane, through the actual management plane to help us to get everything ready the way that we need to as well. Now, when it comes down to the Cisco certifications, you want to make sure that you pay attention to all three, but overall, though, they really do like this idea of you being able to distinguish between the data plane versus the control plane. And that's the kind of key there, is just to make sure you understand the difference between those two.
All right, Ronnie, thank you for that one. And, let's jump back out there to the Twitter sphere, and we'll get our next question. And remember, if you have a question, make sure you throw it out there at hashtag AsksMeAnything. That's how this one came to us. Actually, this one came to us from ourselves. But so this one is, this actually did come from someone else, darn it. So this one is, can you explain in depth the difference between Tor and I2P and the risks, the full tweet is, and the risk for information leakage. So this is a Twitter user out there who's just asking about these two different networks. And Ronnie, it's networking, which I know is your area, but do you have background with any of the obfuscation network technologies?
No, I know a little bit about them. I know what the I2P actually stands for, but overall, though, when you start getting into this is where you're trying to anonymize your connections. Going either across the internet or trying to get even into the dark web, deep web as well. So these are kind of the two technologies, but I don't think I can actually explain in depth overall.
So let me field this one.
All right.
These are two very popular networks that are available for basically hiding your activity on the internet, right? There are many people in many countries where their governments don't allow them access to the full internet,
Right.
where you can actually be punished based on activity. Like if you're going to opposition party websites and things like that. There's illegal activities as well, but there's legitimate uses for this where someone needs to have unfiltered access to the internet without the fear of repercussion from their government or other people. So Tor is a network it stands for the Onion Router, and the Tor network is designed to help hide that. Well, I2P, which is it Internet Invisibility?
It's an Invisible
Protocol?
Internet Protocol. Yeah.
Or Invisible Internet Project?
Yeah, or protocol.
Shoot.
I
Now, hang on, I've got
don't
their
remember
webpage.
exactly.
Let's get it right here.
Yeah.
The Invisible Internet Project. That's it. So sorry, got on the spot. Couldn't remember the acronym there. It is actually originally it was a fork of Tor, so they're very related in what they do. And the idea is that instead of you just browsing straight out to the internet, which would leave a paper trail a mile long that anybody could track back to your IP address and know that you were doing things, you basically connect to a secured network where your traffic is bounced through several nodes before it's dumped out on an endpoint somewhere, and then you're actually hitting the regular internet and browsing along. So when you go to a website, your IP address is not your IP address. It's basically been hidden or obscured by the Tor or I2P networks. One of the challenges, though, is that a lot of people feel like they're completely safe and completely hidden when they're on these networks, but every now and then there's what's called information leakage, and that's what the question we've got today is about, is that if I'm on this network that's supposed to be keeping me safe and hidden, but I still hear about law enforcement being able to capture people or track down criminals that are on that network, then how can my data actually be safe and secret? And I'll tell you, the short answer is that when you're using the Tor network or you're using the I2P networks, you actually are safe. You are secure. Your data is hidden. But the problem is the weakest element in any solution, right? A chain is only as strong as the weakest link. And it's the human behind the computer that is the weakest link in this scenario. And time again, where you hear about a government that has managed to track down a criminal who was using Tor or using I2P, it was almost always that criminal's fault, that they did something that let that data leak out. All right. Now, before I dive into how that happens, if you have to pick between the two, they're actually very similar. Tor, you're basically running into a cloud that then dumps you out somewhere, randomly around the planet, and that kind of hides you. I2P does a little bit more. It encrypts your data in these differing sizes of windows, where it'll actually put multiple pieces of data into the same blocks. So it's got like better encryption. It's significantly faster. I2P is definitely the faster of the two. And I2P lets you pick your tunnel length. The tunnel length is how many nodes you bounce through before you exit the I2P network to get somewhere else. The more nodes you hop through, the more secure you are, but the slower your traffic becomes. So you get to pick. With Tor, you don't get to pick. You just get thrown in there and see what happens. So that's kind of a quick rundown of the differences between the two. But the way data leaks is actually really, really similar for both of them, because it actually turns out to be something very unsophisticated. If law enforcement wanted to like break into one of these networks and track people back, well, there's no logs of who used what IP. There's no record like that. It's very, very difficult to do. But they can do something much more simple, right? For example, if I am on the Tor network or I'm on I2P and I'm browsing securely and I'm hidden, and I go to a website and I log in. I go to Amazon.com or Gmail or any site like that, and I log in. I log in with my username and my password, right? What's that site going to do? It's going to create a cookie. It's going to place a cookie onto my computer so it remembers that I logged in. Well, then, if I disconnect from the Tor or I2P networks, and then I browse out to the internet and I log into Gmail or wherever, well, it sees that cookie. It knows that it's me. It knows that I'm the same person. I'm just from a different IP address. And now, if a government were to subpoena Google or Amazon or whatever, they could turn over their logs and say, oh, Don Pezet logged in from these 3 IP addresses or 10 IP addresses or whatever. And they could see where several of those addresses were Tor addresses or they were I2P addresses. And from there, that starts to give them that paper trail. Now they can see where I exited the network and they can start following that back. And that process is still very difficult and very involved, but it helps them to identify people very, very quickly and far, far easier. We're kind of giving ourselves away. So if you're going to use a network like this and privacy is your utmost concern, you absolutely need to keep your data secret. It's not just enough to use the network. You have to use the network always. And that's where, like, Edward Snowden, right? What he did is he used a CD-based operating system that he booted off of. So it was a read-only operating system, and it immediately would jump out onto the Tor network and secure all his data. And then when he was done, he would just shut down. But since it was CD-based, all the information would go away, like it wasn't persistent. And that way there weren't cookies left behind that would then tie to him and so on. That's how you really protect yourself. So as far as I2P and Tor, there's some DNS leaks that are out there. You have to be careful of what DNS servers you use. You need to use secure DNS servers. There's many DNS servers these days that support SSL. But other than that, they're pretty light on leaks. They're actually really, really secure. It's us that caused the problem.
Yeah, Don, I understand, like, even like I'm going to say it wrong, the I2P network here, that there's less exit nodes, so there's probably more of a chance that if there's less exit nodes, then they could probably, whoever's looking for you could just keep their eye on the fewer number of exit nodes and be able to trace you back a little bit faster as well. So, yeah,
Yep.
It seems like you could find a lot of information by doing what you're talking about.
It's an interesting world, and I feel bad for the people that legitimately need this, that are being harassed or persecuted. That's what these technologies are for. I don't feel bad for the criminals that use it and get caught. So there's all that. But anyhow, so a couple of different things there. All right, Ronnie, let's move on to our next question. Looks like we're going to get back into your neck of the woods. This is a Azure / maybe Office 365 question. We'll throw it in there. This one's from @Jamie Larson. He said, or she, I'm not sure, said, what is the advantage of Azure Active Directory over regular Active Directory or just AD? I could add to that. Like, are they even two different products, Ronnie? So what's our difference there?
Yeah. So when it comes down to it, they are two different products. A normal Active Directory or Microsoft Active Directory is how I normally address it here. Is something that we would establish on our own networks itself. And we, of course, do this for things like authentication and authorization. And we can go in there and create forests, and we can create groups. We can do group policy. We can do, all these different things, which is great. The main protocols that we end up using there is usually going to be, I can't remember, Kerberos. I was trying to make sure that I remember what it was. So Kerberos, and it sounds great. It's exactly what we need for an on-premise network when we have everything controlled the way that we want to. But once we start integrating in cloud technologies, right, things like Office 365, like Don mentioned, well, now the authentication may not be Kerberos-based anymore as well. And inside of Azure's Active Directory, they go beyond Kerberos, and you can start using other types of authentication that's out there. And I can't remember all the acronyms for them. There's so many of them, like OAuth or OAuth.
Yeah, OAuth 2 is what most
OAuth
of them
2,
use. Yep.
and some of these different ones that then can do some of those same things, like the authentication and authorization, but now using those protocols. So for me, if there's a difference or an advantage, it's when you have that mixed environment where you are having the cloud as well as your on-premise type of information. So even though I know a little bit about it because I work with Office 365, Don, is there any other additional differences that we should be considering here in terms of differences?
I think that there certainly are a handful. While you do have a lot of the same functionality, I know some of the stuff that we normally expect, like group policy objects, are really, really annoying to manage inside of Azure AD.
Right.
And when I say annoying, I mean it in like a technical sense. Like, it is more difficult to manage that stuff in the Azure AD. And the way I've always looked at it is, I don't think Microsoft intends for you to use Azure AD as your sole directory service. And instead, what you would typically have is a scenario where you have both. You have a traditional Active Directory forest on premises supporting your systems, and then a federated connection to an Azure AD residing inside of Microsoft Azure. And then that way it becomes more of a resource domain. So you have resources, you have virtual machines and storage and email accounts and all of that are located in Azure AD, but all of your actual user accounts reside in your local AD. And your local AD could actually be replicated up into Azure. Instead of using Azure AD, you can just have a VM, an Azure virtual machine that's running Windows with the Active Directory on it, fully synchronizing down to on-prem. And that way, if you were to lose your on-prem solution, like if your entire building gets destroyed, your AD would still be present and up running in Azure, and it would still be federated with the Azure domain that's up there, so you'd still have that connectivity. That, to me, has always been the ideal deployment model. It's more complex. And anytime we say federated services, like the complexity level goes up by 5 points. So it's not pleasant, but I think that's really the intent. Down the road, who knows? I mean, we could see, it's already to the point where you could say, you know what, I'm just going to have Azure AD. And you can join your laptops and desktop. You can join them to that domain via the internet, so that no matter where they are in the world, you can log in and get that connectivity. But where it starts to create challenges is speed and latency and other problems like that with logging into a cloud service. On-prem really gives you a lot more robustness there. And I think for most enterprises, it'll be a long time before they move away from that.
Yeah, so Don, the question asked about advantages to using Azure over over the on-premise type of AD here. So the true advantage for us is not, I guess it would depend on whether we have more infrastructure on site versus in the cloud or something like that?
Well, all right. So on premises, one thing we have to worry about is having enough replicas, right? So no matter how small your company is, you always need at least 2 domain controllers. If one fails, you need to have a backup, right? So you've always got to have at least 2 domain controllers. Well, as your company grows, Microsoft recommends 1 domain controller for every 1,500 employees, right? Which is a pretty big number. A lot of people use something smaller than that. They'll say like every 800 employees, I want to have a domain controller. But even if you only have 200 employees, if you have 2 locations, you probably want domain controllers in the different locations. And now you've got to worry about replication between them. And if you've worked with Active Directory, then you know what it's like to have replications start to fail or take a long time. It's super annoying. With Azure AD, you don't even think about it. Microsoft completely manages that. I've never had a synchronization problem with Azure AD. It works. We'll steal Apple's slogan here. It just works, right? So it does its thing, and you don't have to worry about it. So from the stability side, the manageability side, scalability, Azure AD is rock solid, and you don't have to blink an eye. You make sure it gets backed up, but that's about it. So that's probably the single biggest advantage of Azure AD. The second advantage I'd say is that it's already integrated into Azure.
Right.
So once you deploy with Azure AD, you can use that authentication through every single piece of Microsoft Azure that you use in your environment. With an on-prem solution, you still have to sit there and do connections for all these various things, and that can become kind of time-consuming and hard to maintain. Now, on-premises, the big advantage is going to be performance because it's local to your clients. There's going to be control. You have control of all of your data, and there may be reasons, like legal reasons, why you have to have that. And then the third one would be cost, right? That we're not paying like a per authentication charge, which when you use Azure AD and you open it up for client connections, you actually do pay. It's a couple of cents per login, which doesn't sound like much, but if you've got thousands of users, that can add up pretty quickly. With an on-prem solution, you don't pay per login. You pay to set up the server, and that's that. So pros and cons for each one. Going forward, as AD gets more and more complex, I think that Microsoft would like everybody to move up into Azure AD, kind of like Apple did with their iCloud stuff, where they said, we're not even going to do Open Directory anymore. Well, they're still supporting it, but they're not going to advance it anymore. We just want people to use iCloud instead. You use their iCloud login, and that's their domain. We provide it for them. So Microsoft is kind of doing that with their live IDs, or whatever they call them this week, and Azure AD. So that technology changes fast.
It really does in this environment that we're in, especially with the cloud stuff that we have. The nice thing is if you're already signing up for something like Office 365, you're already using the Azure AD, regardless of whether you know it or not. It's kind of getting built in the background if you're first signing on for a tenant anyway. So if you don't think you're using it and you're using Office 365, your business probably is.
Yeah, and one thing I've bumped into, Ronnie, I know like if you open up an Office 365 account, it does create an Azure AD for you. But then if you go into Azure and log in with that account, you don't necessarily see that AD, right? It's kind of hidden away. And I've seen people, and I've done it myself, where you go and you create another AD. Yeah. And so now you end up with two Azure ADs, and that can be a bit messy. So you always want to keep an eye out for that. All right, Ronnie, let's advance to our next question. And remember, for those of you watching live or we're recorded, whatever, make sure you throw any questions you've got over to us at #AsksMeAnything. We love to hear things from the crowd because we get cool questions like this next one. I can relate to this next one because I remember when I was learning Cisco equipment, this is something I dealt with. The question is, NVRAM and Flash, they're both persistent through reboots. So what is the difference? Why do we have these two different things?
That's actually a really good question. The reason why is that this is where people get confused when they start taking a look at a router for the first time. If they've come in from the support side and they begin to deal with the router, they're not sure how that router fits into the scheme of things when they've just been looking at desktops and servers. Well, when it comes down to the router itself, you can treat it almost like another PC, just about. There's different components to it. That's what I mean by that, right? So on a regular PC, we have a CPU, we have a motherboard, we have storage, we have RAM, we have stuff like that as well. And then on your computer as well, you also have a little bit of persistent memory that's there to keep things like the time clock going and some different things that are happening there too. Well, when it comes down to the Cisco router as well, you still have those same components that are in there, but now they've kind of divided it up a little bit more detailed in this way where you have to pay attention to it if you're going to be configuring these things. So for us, NVRAM stands for non-volatile random access memory. And this particular RAM is exactly like it sounds. It is RAM, but it's persistent through reboots. Then you also have Flash, and Flash is equivalent to the idea of a hard drive in a regular computer where we can store information. Now, it's probably not going to be like a terabyte or 500 gigs or anything. On older routers, you might see that they're as small as 16 megs or so, or maybe 64 megs on some of the Flash. I can't even tell you. It may be even lower than that for all I know. So you will find these devices here. Well, if you store something in Flash, that's like writing it to a hard drive. It's not going to go anywhere when you reboot the computer because it's written down in Flash. But when we start writing other things, such as our running config to our startup config, well, that gets stored into that NVRAM itself. So when you reboot the computer, what it looks for is the startup config, and it can pull it directly out of the NVRAM and then put it into, of course, your running memory at that point, and then you're off and ready to go. Well, what keeps it NVRAM is the key here that most people get confused about. There's a little battery inside of the actual router that keeps that RAM charged even when you reboot it or when you turn off the router. It actually keeps the NVRAM charged enough to keep that memory active and going, so that when you're ready to reboot, it can bring up your running or your startup config right after it loads up your iOS, and then you're ready to go. So on both of these here, that's why they're both persistent, but they're not the same. One is used, of course, just for storing that small file, which is going to be our startup config, and the other one's used for normally storing just the iOS itself. But I've seen people back up their configs to the Flash as well.
Yeah, no, the short answer to this question, if we go back to NVRAM and Flash are both persistent reboots, so what's the difference? The difference actually boils down to one word: history.
History.
Right? So 25 years ago, Flash was pretty expensive, and it wasn't particularly fast either, right? But also, you couldn't write to it too many times. The more you wrote to it, the faster it broke down. And because it was expensive, they wanted to last as long as possible. So on Cisco routers, they used Flash to store the iOS image. Because how often do you write a new iOS image? Not very often. Back then, updates didn't come out like they do now.
Right.
You can update every single week these days. But back then, an update might come out once a month, once every 2 months. So that Flash could last a really long time. But your config file, that changed all the time. And so that they would store in NVRAM. It was battery-backed memory that could last a lot longer. It could handle a lot more writes than the regular Flash could. So that's why there were two different types of memory. Well, over the years, Flash has gotten better and better and better, and that technology's come a long way. I mean, now we have SSDs in our laptops because we can write to them practically as much as we want for 4, 5, 7 years, and they don't fail like they used to. So on newer Cisco routers, if you go and buy a brand new Cisco router today and look, it's going to have NVRAM and Flash, but the NVRAM is fake. It's actually just a partition on the Flash.
Oh,
so
nice.
on any Cisco router made in the last 3 to 5 years, there isn't an actual NVRAM chip on it anymore. It's just using Flash because the write degradation is not there anymore. So the thing is, Cisco has to maintain compatibility and stability. They've done things a certain way for 30 years. They can't just change overnight and say, oh, we're going to get rid of that. So now they emulate the NVRAM. And if you ever poke around in the hardware on a Cisco router, the Cisco ASAs are the same way, you'll find where while there is a partition that's called NVRAM, it's just that. It's a partition. It's stored on the Flash, and a lot of them don't even have that battery anymore because they don't need the battery-backed clock. Because a lot of them leverage NTP servers and all to sync that. Some of them do have lithium batteries built on them that charge, or lithium ion, I don't know, whatever it is. So they charge and maintain their stuff that way. But kind of a neat thing because we still see NVRAM, but it doesn't physically exist.
Yeah. So just make sure that if you're asking that question because it's confusing as you're reading about it or as you're studying for the exam, make sure you differentiate them. They'll still call that out pretty good. So make sure you take a note of that too.
Yep, absolutely. All right, Ronnie, let's jump into our next question. We've got another one that came at us from the Twitter hashtag AskMeAnything. And this is, how is an IPv6 Anycast address secured?
All right.
So IPv6 Anycast. Now, Ronnie, I know that an IPv6 Anycast address is one address that you attach to a device, and that device will answer on any interface that it has, unlike a normal address that would just do one interface. So how do we go about securing something like that?
That's kind of one of those unusual questions here, right? First of all, what Don was explaining is absolutely key and critical for us. But when it comes down to it, it's the same thing because of the way that Anycast works. With Anycast, because it actually does that, it will answer to those multiple interfaces, like you said, and it's directed by a routing protocol, to allow you to actually figure out which one is the one to nearest address that it's going to give you to answer. Well, securing that routing protocol is kind of the key aspect of this as well, and also providing authentication between those routers too. One of the problems with Anycast addresses that we tend to have is that when it tries to communicate, right? Anybody can actually communicate with that device, and then you can end up with like man-in-the-middle attacks, and where somebody spoofs that Anycast address, you name it. Well, putting authentication in so that you know that you're not connecting to a device that can't authenticate is kind of key too. And of course, even providing encryption on those, for the routing protocol is also going to help you out as you start running those as well. So you can do that and make sure that works. Now, in the background, its nature, like with anything on IPv6, there's not a lot of configuration that needs to be done. So if you're communicating that device because it's automatically doing like neighbor discoveries and router advertisements, I was trying to remember the terminology for this, and things like stateless. I'm starting to try and pull all this information up all at the same time here. Stateless auto config, because you're getting those addresses and making sure that you're putting yourself on the right IPv6 network. Well, all of that also, of course, has to go through, for us here, that same process and make sure that we get the same information that we need from the right places. So again, authentication is key. But at that point, there's a protocol out there that's called SEND, which is Secure Network Discovery. And that is what is also used to help provide security as well. It requires, some type of verification of that device. So that's where that, setup of the authentication and everything else comes in. But then it also requires something else for us too. So it's like it says, hey, if you're running digital certificates, validate that certificate is what it needs, or a signature, I should say, not a certificate, but a signature. And then it can ask for authentication when you're doing the network discovery or any of these other things that are out there. So you can set up a little bit more security, but in the end of it, I think it's the idea of securing and encrypting even the routing protocol that we're using is probably going to be of the biggest help. And of course, making sure that you harden the actual device too. Okay.
Yep. Now, I know one thing that I've encountered, Ronnie, is that Anycast addresses made me really have to rethink how I apply ACLs. Right. So with access control list, we control what traffic's allowed into our router destined for an address. And in the past, you would build it based on the address that was attached to the individual interface. But with Anycast addresses, you don't really know what interface, do you?
No, and that's one of the things, like one of the RFCs that has kind of been, I guess, deprecated at this point, said that, look, you cannot use an Anycast address as being a source address or a destination address. So it's kind of weird in how that works when the ACLs come in. But yeah, the idea of ACLs, which I forgot, that's the key, what comes on here. But setting even stuff like ACLs up to make sure that you're getting to the right interfaces, or you're limiting the amount of access that's going on, is also going to be key here too.
Yeah. Now, if you're studying for the exam, one thing you'll want to take a look at are the zone-based firewalls. Because what Ronnie mentioned, it sounds kind of weird. Like you can't use an Anycast address as a source or as a destination. Well, that means you can't use an Anycast address, right? Well, if you pop that Anycast address into a particular zone, you can filter traffic as it passes from one zone to another. It's not based on the address anymore. Right. It's based on transiting zones. And that's a real important thing. On Cisco ASAs, on those firewalls, they do zone-based no matter what. That's how they work. But on routers, you actually have to choose to do the zone-based firewall. That is on, I know that's on the CCNA security exam, Ronnie. Is that on the regular CCNA now?
It is not.
It is not,
yeah,
okay.
It is not yet, but it is in the CCNA security, yes.
All right, so for those of you studying for that certification, definitely be aware of that and know how to configure it from the command line, not just the GUI, because that exam changed a good bit.
It has.
I'll throw you for a loop. All right, Ronnie, it is time for our last question. So we are going to tackle this one, which is, do we have any content like CWNA or similar involving in-depth wireless topics? CWNA is the Certified Wireless Network Administrator. And Ronnie, to my knowledge, I don't think, I know we don't have CWNA. Right. Do we cover wireless configs or like Cisco AeroNet or anything in our episodes?
Not currently in the current offering that we have, but we are taking a look in the future about doing more of wireless type technologies would get you toward that in-depth coverage that you would have in the CWNA as well. So anything is possible. That's what we like to say. If we can find the right person to do it, a lot of times, and if we can actually make sure that everything comes together the way that we want to present it is also the key. So timing and make sure that we have who we think is actually right to do the thing. That's the key in what we'll do.
And one of the other big challenges we have is the hardware.
Yeah. True.
I taught that course years ago, or the CCNA wireless, not the CWNA. And you need to have a bunch of access points. And when you have a bunch of access points all in close proximity to each other, it creates rather unique problems. And so that's a challenge that we have to
radiating
overcome.
there, huh?
But we'll work to get that one in there at some point and check that out. But all right, well, that wraps up the questions I've got in the hopper. So Ronnie, I want to thank you for being on the spot with us today. I think you managed to answer every question.
Well, I did, and I thank you, Don, for helping me on some of the things that I forgot, because I'm just pulling it off the top of my head here, trying to remember a lot of things, but I do appreciate it as well.
All right. So, okay, so that's the last of our questions, but let me just mention to you viewers out there, I've said it many, many times throughout the episode here. If you have questions, we love to see them live during the Ask Me Anything, but we take questions anytime, 24 hours a day, 7 days a week. Throw your questions out there. Make sure you stick that hashtag on there. Hashtag Asks Me Anything. We'll see it. We'll get that answered as part of our Ask Me Anything segments. Remember, if you are an IT Pro TV subscriber, that puts you to the top of the queue. We make sure that your questions get tackled as soon as possible. And if we can't get to them in the podcast or in the segment, we'll try and at least tweet out an answer to you or get an answer to you one way or another. If you're not an IT Pro TV subscriber, well, don't hesitate to throw your question up there, though. We love to get questions from everybody. Everybody benefits from that. So throw them out there. Do remember, if you want to learn more about really any of the topics that we talked about, well, maybe not CWNA, right? But the other ones, if you want to learn about IPv6, if you want to learn about zone-based firewalls, if you want to learn about most of the other technologies, you can find a lot of it right inside of the IT Pro TV library. It's all posted right in there. Check out our website at itpro.tv and see if our content is right for you. If you're already a subscriber, thank you. And as always, make sure to throw your questions out there and continue learning. All right, one last comment I want to mention is that we do have a webinar coming up. If you're watching this live, then Thursday this week coming up, we have a GDPR podcast. It's actually on GDPR Eve, May 24th. GDPR, What IT Pros Need to Know. Mr. Adam Gordon, one of the other SMEs here, is going to be doing that presentation. It's going to be exciting. It's going to be fun, thrill ride, action-packed adventure with all the information that you need to be aware of with GDPR, taking full effect on May 25th to make sure that you're taking the right steps to ensure that you're handling privacy data as well as possible. So be sure to register, sign up, and check that out. As always, that is going to be some great information there. And if you can't be at the webinar live, then you will be able to have a chance to watch that recorded. It's available, and just something that's able to be checked out. All right. Well, Ronnie, do you have any parting words for us before we wrap this one up?
Well, no, just again, thank you for also submitting those questions as well. It does put us a little bit on the spot, but we're going to get used to it because we like having something like this which directly interacts with you. So thank you, and keep sending those questions.
All right. Well, ladies and gentlemen, that wraps up our segment of Asks Me Anything. Be sure to tune back in as we continue this adventure almost each and every day. And otherwise, we'll see you out there on Twitter. Hashtag Ask Me Anything. Thank you for watching.